This is number 20. In this one, you are looking for the frequencies or abundances of two isotopes of copper. You're going to be given the overall average atomic mass of copper and then the various isotopic masses for each of the two isotopes that we're looking for the abundance. Remember, frequency has to do with the amount in decimal value, where abundance has to do with the amount in percent. So we're going to solve for it in frequency, and then we'll convert it into abundance at the end. So let's kind of look and see what we're given here. Now, just to make this simple, we're only going to do problems that have two naturally occurring isotopes. When you're dealing with frequency, your total for frequency is going to be equal to 1. For abundance, your total is going to be equal to 100, which represents your percentage. And then the frequency, remember, is a decimal value of abundance, so all we got to do is divide this by 100 to get it to the 1. So since our total frequency is 1, what we're going to do for one of our isotopes, in this case, we're going to be looking at two different copper isotopes. So we have one that's 63, has its mass number for copper. We're going to let its frequency equal X. And then for our second one, which we are given our isotope of 65 copper, we're going to let this frequency equal 1 minus X, since our total frequency is equivalent to 1. So if X had been 0.2, then the frequency for this one would be 1 minus 0.2, or 0.8, for a total of 1. So this is why we let this one equal 1 minus X, which makes the entire total of the frequency, where X is the frequency of our second isotope. And this will be the way it is in all of these types of problems. So now we're going to go back and look and see what else is in this problem. So it's given us the actual isotopic mass here of 62.9296. So that's there. And then for the copper 65, it's 64.9278. And this is in AMUs, or atomic mass units. So we're going to actually use those values instead of using the 63 and the 65 because it's more accurate. Now remember when we did average atomic mass in problem 19, that is equal to your frequency of your isotope times its mass, or in this case the isotopic mass. And you're going to add that to the frequency of the second isotope times its mass. And that's all we're going to have in this one, since we only have two isotopes. Now if we go back and look at our problem, it's going to tell us that if copper has an average atomic mass of 63.546, what is the percent abundance of each isotope? So first we're going to solve for the frequency, and then all we have to do to change frequency to percent is multiply by 100. So we're going to start off then, our average atomic mass that we have, they're giving us, is 63.546. So we actually have that. We set up our frequencies as being X and 1 minus X, so we're going to let the frequency of the first isotope be X, and its atomic mass was 62.9296. So we're going to set it up this way, and then we're going to add that to the frequency of the second isotope, which is 1 minus X, and then multiply it by its mass, which was the 64.9278. Once you have it set up, the rest is math, but that's where it gets a little difficult sometimes, so we'll kind of walk through each step. So here we have 63.546 is equal to, so we'll multiply x times this value, so it's going to be 62.9296x. And then plus, now when you have something like this, 1 minus x, we have to use what they call the distributive property. So we're first going to take the 1 and multiply it by this number. So we have 64.927 without an x. And then we're going to pull this down and we'll multiply the minus x times that number as well. So it'll be minus, and then 64.927x. So if you have a plus or minus sign and you're multiplying it by something, you'll take the first number, multiply it by that number, as we did here, and then we'll take our second value, in this case the minus x, and multiply it by that same number. Once we get this, then what we want to do is put all of the like terms together. So we want to put all of our x terms together. So I'm going to just do this individually steps. So 62.9296x, and we're going to subtract 64.927x. We'll do that. And then I'm going to keep this over here since we haven't done anything with that yet. And then we'll keep this over here since we haven't done anything with this either, okay? So we're going to basically just subtract these two numbers from each other so that we can get a minus 1.9982x, and then we'll just pull all the rest of the numbers down. So this is still over here, and this is still over here. And now what we need to do is get the terms that don't have x together, so I'm going to need to subtract this from both sides. If I subtract that from this side, that's going to be cancel out, right? And if I subtract it from this side, I am going to get a minus 1.3818. And I'm going to set that equal to the minus 1.9982x. And then finally, we want to divide both sides by what's with the x, which is the minus 1.9982. That'll cancel here. That'll leave x by itself over here. We'll divide this out, and you're going to get a 0.6915. Since we let x up here be the frequency of our copper 63, then this is going to be the frequency of our copper 63 that we just solved for. And then we let the 1 minus x be the frequency of our copper 65. So to get that value, all we have to do now is put this value in place of x. So 1 minus 0.6915 is going to be equal to 0.3085, and that's going to be the frequency of the 65 copper. Remember, when you add your frequencies together, they're going to be equal to 1. So if I took my 0.6915 and added it to my 0.3085, I should get approximately 1. Now to get abundances, all you have to do now is take each one of these frequencies and multiply them by 100. So for my copper 63, my 6.6915 would be equal to 69.15%. And then for my copper 65, my 0.3085 multiplied by 100 would give me 30.85%.